Alright guys, welcome back to the final topic in our video series on surds, which is going to be on rationalizing the denominator. So what does rationalizing the denominator actually mean? So let's break this up step by step. So let's go with denominator first. Now hopefully we remember that in a fraction we have a numerator on top and a denominator on the bottom. So rationalizing the denominator means we're going to be focusing on this bottom part of the fraction. So what does rationalizing mean? Now, in the first video in this series, we went over what irrational and rational numbers were. So remember, having a surd, a number that can't be represented without being in its root form, is an irrational number. So if we were to rationalize a number, then what we would be doing is we would be taking something from this form into a form that was a rational number, or a number that could be represented as a fraction. Now you might be thinking, hang on, how do we do that? So how does this rationalizing the denominator actually work? So this is what we're going to do in the case that we get asked to rationalize a fraction that has a surd on the bottom. Now this surd on the bottom can be anywhere, so it can be in a form like this with just a simple surd on the bottom, or it could be something along the lines of, something with this form, or better yet, it could even be in a trickier form with something like this. So what we're going to do is we're going to go over how we can get rid of this surd on the bottom while still keeping this fraction the same number. So what I mean by keeping it the same number is this. So we can have fractions such as 1/2. So remember, 1/2 is the same thing if I split this circle into two and I just take one of the two slices. So one of the two slices. But we can still have the same fraction written out in a different way if we were to split this circle into, say, 4 parts, and then we take 2 of the 4 pieces. So again, I end up with the same amount. So these fractions are the same. So the whole thing behind this, when we rationalize the denominator, we don't want to say we have 1 on root 2. We can't change this fraction so it simply is root 2 on 1, because that's not the same thing. Instead, we want to put it into a form so that it still equals 1 on root 2. So how are we going to go about actually doing this? So remember, from a couple of videos back, we learnt this property where the root of a number squared just equaled that number. So what we're going to be trying to do is use this property to take our surd and turn it into just a normal number, so a rational number. But the trick here is we want to make sure that this is the same number. So let's take an example of, let's just say we had root 2 plus 1 over root 3. And we want to rationalize the denominator. So we want to turn this denominator into a rational number. So how are we going to utilize this property? Now, usually what we want to do when we rationalize the denominator is we want to times this fraction by 1. Okay, because anything times 1 is the same number. So remember, there are many different ways to write 1. So you can write 1 as 1 over 1. You can write 1 as 25 over 25, 69 over 69, whatever. They all equal the same thing. So what we're going to do in order to rationalize the denominator is we want to times this in a way that will turn the denominator rational. So if we times it with a denominator of root 3, what are we going to have to put on the top? Root 3 as well, right? Because then root 3 divided by root 3 is the same thing as 1. So we're timesing it by 1 still, which will give us the same fraction. So now we're going to see this squared property come to fruition, because when we multiply across, like we would do when we multiply fractions, we see on the bottom we get root 3 times root 3, which is what? The same thing as root 3 squared, and we know from our property that that's the same thing as 3. So then we have a new denominator, which is 3, and the top is going to be a binomial, which we did in the previous video as well. So we're going to times root 3 by 2, which is going to be root 6, and now root 3 by 1, which is going to be root 3. Now, the trickier rationalizing the denominator questions actually have a denominator a little bit trickier. So let's just say we have a denominator that looks like this. Well, we can't simply just times it by 5 plus 2 root 3 on 5 plus 2 root 3, because that's not going to give us a rational number, is it? So we need to remember back to our binomial products and remember the difference of 2 squares. So remember, in our difference of 2 squares, that was when we had something in the form of this. So if we use our 5 plus 2 root 3, and then we times it by 5 minus 2 root 3, look what happens when we expand it. So if I go ahead and do this, I get 25 for my first one, I get minus 10 root 3, and I get plus 10 root 3, and then over here I get minus 4 root 9. So as you can see, these two middle ones will cancel out, and that'll get rid of 2 irrational numbers there. And what am I left with over here? Root 9, which is going to be the same thing as 3. So I end up with 25 minus 12, which is going to be 13 on the bottom as my new denominator. So if we go back to our original question, we're going to need to rationalize this denominator making use of this difference of 2 squares feature. So we're going to put that 5 minus 2 root 3. So if we have this same binomial sort of thing happening on the bottom, and we will get rid of all our irrational numbers. So what are we going to have to do to make it the same as this over here? We need to multiply it by 1, and we can rewrite 1 over here as 5 minus 2 root 3 over 5 minus 2 root 3. So if you go ahead and you multiply across, like we would do with all our fractions, we end up with, so we know on the bottom from before that we get 13, and on the top we can just multiply through this binomial, which we've gone through in previous videos. So we've got our 2 times our 5, which is 10, and we've got our minus 2 out for this next one, so we have minus 4 on root 3. So this is the trickiest form that they're going to give you of rationalizing the denominator, and we're going to go through some more examples in the textbook in the next video.